moving the vertex. So we're once again back on Desmos. I've set up this equation y equals x squared plus k with a slider for that value of k so that we can look at what happens to the graph as we change what k is equal to. So the vertex right now, when k is equal to 0, we have just y equals x squared. The vertex is 0, 0. But what happens as we change k? And let's drag k up to 1. Well, if x equals 0, then y is obviously equal to 1. So by changing k, what we do is we change the y value of the vertex. If I drag it up to 5, the y value of the vertex is equal to 5. And similarly, I could take it down below 0, and all it does is it turns the vertex into negative values. So again, if x is equal to 0, k is equal to -3, then y is equal to -3. So k can actually tell us, if we have an equation of this form, we can see the y value of the vertex, just like that. If y equals x squared is what we call our base function, then y equals x squared plus k moves the vertex up or down, and we call this a vertical translation. A vertical translation of y equals x squared. So y equals x squared plus 5 is a shift up 5. It vertically translates the function up 5. And y equals x squared minus 9 is a shift down 9. So next up, I'd like you to consider the equation of x minus h squared. So what I've done now is I've graphed y equals x squared as a dashed blue line, just as our base function, so that we can see what happens when we subtract a value of h from x. And, you know, related to what we were just doing, I bet you can guess what's going to happen as we set h to 1. You can see that it shifts the parabola, and as I shift h upwards, it shifts it to the right. But notice that this is x minus h. So what this equation looks like is x minus 3. So by making h more and more larger and larger, I shift the graph to the right. So x minus 5 has shifted the vertex to the right 5. And as I shift h back to 0 and then over into the negative values, so let me pop it here. Now what this equation looks like is I have x minus -4 squared, which is x plus 4. So by having, and I'll just type it in so we can see it even, y equals x plus 4 squared. So x plus 4, positive values here beside the x, shift the equation to the right, or sorry, shift the equation to the left 4. So you have to be careful that, you know, shifting happens sort of almost opposite to what you would expect, which is that when x is a positive number, or when h is a positive number, we are shifting it to the right, but we have a negative in our equation. So we'll get a little more practice with this in a bit to show you what that means. Just to recap what we saw, y equals x squared is our base function, then y equals x minus h squared moves the vertex side to side. So this is called a horizontal translation. And we have to be careful because y equals x minus 3, that's according to our equation, right? That's like x minus positive 3 all squared. And so we can see now more clearly this is actually a shift to the right. And it's because it doesn't go exactly like you'd expect. And if we have y equals x plus 1 squared, this is actually a shift to the left. Because again, this is x minus -1. That's what gives you the plus 1. And you can prove that this is true. It just seems sort of counter to what we would expect. But you can prove it by picking values for yourself and graphing what the graphs would look like. I suggest doing it online with Desmos for yourself to really see how that works. But either way, you have to get used to this and you have to be ready to look out for this. So x minus 3 squared is a shift to the right of 3, and x plus 1 squared is shifting the vertex to the left 1. Now when graphing y equals x squared, remember that it's really easy to graph if we remember the pattern over 1 from the vertex, over 1 up 1, over 2 up 4, over 3 up 9, since we're squaring x. So now we can actually use our knowledge of these shifts of that base function to graph our equations really quickly. So we're going to graph y equals x minus 4 squared minus 3. And we're going to do it by recognizing that x minus 4, that's a shift to the right four, and minus 3, that's a vertical shift down 3. So our vertex is actually at 4, -3. So if we were normally to start at 0, 0 for y equals x squared, we actually have shifted it to the right 4 and then down 3, and here's our new vertex. And it opens upwards because it's positive here, and we can graph this function very quickly by doing our over 1 up 1, and then over 2 up 4, so counting 1, 2, 3, 4. So here's our points. Over 3 up 9. It's going to put us up to here. So again, over 1 up 1, over 2 up 4, over 3 up 9. And now we can just go ahead and draw that smooth curve, and there's half the parabola, and then we do the same thing on the other side. Over 1 up 1, over 2 up 4, and over 3 up 9. And there is our parabola. And so you can see how quick it is to graph something that's written like this, because we can identify where the vertex is and then just apply those rules to graph it.